Hi guys, welcome to Most the Academy. I am Engineer Oyedi. Today what we have before us is the Organic Chemistry chapter, which is the chapter 19 of the syllabus. As usual, if you are new to my channel, you can consider subscribing to the channel, provided you see anything helpful in this video. So what I'm going to be doing is I have a couple of questions on this, your topic, the whole topic of organic chemistry. That is, if you're writing Jamb, I think this is going to be helpful, or any other kind of ordinary level examination, say Waec and so on and so forth. So before you can actually get maximum knowledge of this video, I believe you might have had one or two knowledge on organic chemistry. What I'll do mostly in this video, because I have about more than 350 questions, which I'm going to be solving. So I'm going to do them in batches, if you are not new to my channel, because of, I don't want it to be too lengthy, and also I want it to be like, I won't just be picking the answers, I'll be taking you through some important things you need to know about the questions. So though I'm not going to be going into too much of details, so I expect you to have a prior knowledge about all these things. So let's start with questions. I think this video I should be able to do 50 or more than that. So depends. Once it is 45 minutes, I'm going to stop this video. So let's start. Now the first question we have, this is chapter 19 of the organic chemistry. We are given this now because I don't want obstructions. I want you guys to see it. When large hydrocarbon molecules are heated at high temperature in the presence of catalysts. Now important point there is a breakdown of molecule due to heating. So whenever you see breakdown of molecule due to heating, that is what comes to your mind is breaking down in organic chemistry means cracking. So there are two types of cracking, but for now I'm not going to talk about that. It can be catalytical cracking or it can be thermal cracking. So for this question, I think it is best for you to know that when you are breaking down, it is cracking. Polymerization simply means bring it together of two or more monomers to form a giant structure which we call polymers. In sequence, we are going to be talking more about that. So for now, let's limit ourselves to what we have. This guy is going to be the answer to that. So cracking is correct for the first question. I hope you get that. The second question. Now the reaction between organic acid and alcohol in the presence of acid catalyst is known as starch. Now organic acid means what we call carboxylic acid, alkanoic acid. So basically there's this belief that when alkanoic combine with alkanol, you can keep it in mind. I think these are basic things. Then you are forming what they call esters plus water. So it is just like this almost every time. You are going to see this question repeating itself. So basically the acid is always an organic acid. Alkanol reacts with alkanoic in the presence of a catalyst, gives you what? Esters and water. The process is called esterification. So keep that in mind. And esterification is characterized or always comes with what we call sweet smell, because esters have what? Sweet smell. That is why most of them are used as fragrances. So you keep that in mind. I think correct answer to that is also choice C, as you can see. Apologies about my handwriting. I just want you guys to see. Now the next one is asking us to pick or to name the IUPAC of the compound we have here and the other one we have there. So basically, I think this is also a very simple question. Now, there is what we call functional group in organic chemistry. Now, when we talk about functional group, for example, there are different types of functional group. For example, what I have on the board when I talk about esters. When you say organic acid or alkanoic acid, basically you are talking about the functional group we call the COOH. Now, whenever you see this COOH functional group, basically, I told you it's going to be a quick question and answer stuff. So this COOH is a functional group that predicts both the physical and chemical property of an organic compound. Not only the chemical property, it also helps us to identify the physical property. So basically, if you watch this guy, there is COOH group, and from that I said this is the acid group called alkanoic acid, please, or organic acid. It might come in any form. So basically this guy is an acid. Then there's this simple way of counting the number of carbons. So for example, if you count the number of carbons, one carbon and two carbons. Now two carbons always go with the word ETH. So now if you have ETH, then this is called oic acid. So we call this one ethanoic acid. So what you have at the first family here is the ethanoic acid, which I believe is so simple for you to name. Please keep that in mind. Now for the second one, you have a CH2 double bond and CH2. Yes, that is the clearest one. You might not see it well. There's a double bond in between that guy. Now the double bond there is telling you that what that particular substance is a compound is unsaturated. The compound is unsaturated. Now, what unsaturation means is when you have a double and a triple bond. Basically, this is called alkanes, and these are called alkynes. You can see no space to write, but that will not disturb my explanation. So, alkanes and alkynes are unsaturated. Double bonds means alkanes, triple bond means alkynes. So, don't let us waste time. Now we know the answer to this question, and I think it will be better for us to just pick the correct answer now. We know the first one is organic compound, which is ethanoic acid. Now, there's another thing I need to talk about, because it's important to know some other names, because other names are going to help us here. Because look at the first option, we have acetic and ethane. Basically, you know, this guy double bond, there are two carbons. Two carbon is eth, but I told you then it is what? ENE. So it is not ethane, it is what? Ethene. So we can cancel out option 1 so that I can move. I can come to this so that I can see clearly. So that we can move, let's do something very fast and move. So we can see that option A is wrong. Then on the other hand, you can also check the first option, acetic acid. Yes, because many times you can also see question telling you acetic acid and you'll be like, what does acetic acid mean? I'm going to the next question, so I have to scroll. Now other options here. Now guys, we are now at this side. Maybe I should come like this so you can see. Now look at option B, ethanoic acid and ethene. So I won't go into too much of details because I've already named that as ethanoic acid and the second guy there as ethene. So guys, we know that the answer to this guy is choice B. So we don't need to waste our time. So let's move to the next question. The next question says, which of the following is not a member? That's question 4. I hope this is not too tiny from the screen. Please let me check it out for my recording stuff there. Yes, hope it is not too tiny. Okay, fine. So the next one, like I said, is which of the following, I have to come here. Now, which of the following is not a member of homologous series of paraffins? Now, the only thing you keep in mind here is just mastering the names. Now, alkanes are known as paraffins. Paraffin is a single word, yeah. Paraffins, permit my spellings. Alkanes are known as olefins. You can write it down for the sake of next question. Alkanes are known as olefins. And alkynes are known as what? Acetylenes. So I hope you can write down, no space to write all this stuff. So I'm sorry, I'm going to, wow. So that's that. And so thank God I can bring it back. So I think that one has given us some kind of justification or interpretation to the question. So for example, now we are told to see the one that is not the family or the series of paraffins. I said paraffins are alkane. Now in junior classes you were told that alkane has the general formula of alkanes. They have the general formula of CnH2n plus 2. So basically, anyone that does not fall into the category of when you multiply by 2, you also add 2 to the hydrogen family is how. So let's take some example. We can't see the number well, but I think the first one is C3H8. So C3H8, 3, N is 3. You can see that the other one will be 8. Because 2 times 3 is 6, 6 plus 2 is 8. So that is a family of what? Paraffin. The next one is C5H12. 5 times 2 is 10, 10 plus 2 is 12. That's also falling. The next one I can't see, but the one I think I can see is the last one. I'm having C24H48. So looking into that one, it does not fit into this formula. Because when N is 24, 2 times 24 is 48. 48 plus 2 is 50. It should be C24H50. So I'm very sure others are going to be the family of us. So that's particular option E. This one I can see. I can see that this particular option is wrong because this is an example of olefins. I hope you guys get that. So that's that about that. We can go into question 5. So we are going to be doing a lot of questions today, but I will definitely need to be taking water. You know what I mean? So number 5 is which of the following? An example of alcohol is that I think I've talked about that one in question 1 and 2. How do you know alcohol? How do you know organic acid? Organic acid, just check their functional group. COOH, that's alkanoic acid. How do you know alkanol? Just check the functional group of OH. They are classified into 3: monohydric 1OH, dihydric 2OH, and trihydric 3OH. Now, you can also have primary alkanol 1 methyl group, secondary alkanol 2 methyl group, tertiary alkanol 3 methyl group, or more than 2. So these are things you keep in mind. So without any further ado, which one has OH? Will be an alcohol, which is also known as alcohol. So it goes without saying this guy is going to be the answer as well. I hope you guys are following because we have a long way to go, like I said. So, and I don't want us to make any mistake or be a part of any mistake. So number 6, look at number 6. Now, the most common type of chemical reaction between alkanes is starch. These are basic. That's why I like organic chemistry and this type of questions. They are going to take you from 0 to hero and from hero to superhero. So that is the aim of this class. You can join us on our online private class. We do that Mondays, Wednesdays, and Fridays. Now, look at this. The most common type of reactions which alkane on the go is this. Now, there's this common reaction that alkane only on the go. You guys know the answer already. Substitution reaction. So, alkane react with halogen in the presence of sunlight, which acts as a catalyst. We are not writing too much of stuff, but we are picking answers. So, alkane undergo substitution reaction. Alkanes and alkyne undergo the other type of reaction we call addition reaction. I hope you got this. And if you are having issues with that, we can still help you doing them later. Explaining the concept, you can watch our organic chemistry full concept video. But if you are writing Jam, I think this is better than watching long video. So that's that about that. We move to the next one. Now, question 7. Now we have 2 gases or 2 gas cylinders contain ethylene. Ethylene is 18. It is written in bracket for you. And acetylene. Acetylene is ethyne. Now the question is, one test which can be used to distinguish between them is this. Now, let me be quick to let you guys know something. Now, to distinguish, because I said in the other video, the other question, that when you have alkanes and alkynes, they are both unsaturated. Now, it is only alkane that is saturated, and you can easily use something like bromine water, KMNO4. When I say bromine water, I love abbreviation, no space to write, so I have to abbreviate. KMNO4, the other guy, K2Cr2O7, to distinguish. Now, it is very easy to separate saturation from unsaturation. Saturated hydrocarbon is alkanes, also called paraffins. Now, alkanes, ENE, the one with double bond, and alkynes are unsaturated. And to separate 2 unsaturation or 2 unsaturated hydrocarbon, like what this question asks us, the only thing you can use is what we call ammonica copper 1 chloride. Let me write that for you. Ammonica copper 1 chloride. Or you can also use what they call silver nitrate. Yes, that will also help you to distinguish. No space, but at least you can hear my voice. Then what will be the effect? Because that is another thing you need to keep in mind. What will be the effect of you using ammonica copper 1 chloride? Now, because looking at the option, now you are distinguishing between alkanes, the double bond, and alkynes, and both of them are unsaturated. The major thing you just need to keep in mind is that when you react, let's take the option 1 by 1, passing each gas through bromine water, both of them will give what? We definitely react with bromine water because they are both unsaturated. Both are both unsaturated, and any unsaturation, the word unsaturation means it undergo what? Addition reaction. That's the meaning. You know, we said the first one, which is saturated, undergo what? Substitution reaction. I hope you guys are getting this thing. So what I'm saying in essence is that both of them is going to react what? They will change the color of bromine. And option B says pass each gas through dilute potassium permanganate. All those ones are what you can use to test for saturated compound because they won't react. Are you getting it? So both of them will react and decolorize what? The purple color of KMNO4. The choice C says pass each of them through silver nitrate solution. Now this is where something is. Now, about silver nitrate solution, because we have to be careful about silver nitrate solution. I said silver nitrate can be used to distinguish. Yes, it is possible. But the only thing here is that when you react, if you use silver nitrate on both alkenes and alkynes, both of them are going to react. That's another thing you have to keep in mind. Now, the next option says passing each gas through ammonium copper 1 chloride. Yes, that is one thing. Now, this distinguish, in fact, I think I've quoted that this particular one is what is used truly to differentiate between two unsaturated hydrocarbon. So whenever you have two unsaturated hydrocarbon, which is alkenes and alkynes, pass them, each of them through what? Through ammonium copper 1 chloride. What you see is that one will give you what? One will decolorize, one will not react. Please note that. Now, what happened in the reaction is the color of what ammonium copper 1 chloride before is reddish brown. Yes, reddish brown. So at the end of the reaction, what you are going to see is what? The one that has triple bond will definitely what? React with it and what? Decolorize, that will change the color from what? From that reddish brown to what? To colorless. So that is just a good example of how to differentiate between two what? Two unsaturated compounds. I said I don't want to explain, but one thing about all these things is it is very difficult for you just to be making answers without explanation. Look at number 9 or number 8. Organic compound X, we don't know the organic compound, has the following properties. I think Roman figure 1 is it is not mixable with water. That means it does not what? Mix with water. Then option B says, let's see, it has a boiling point of 77 days. That means the boiling point is not that high because it's not even up to water. Number C says it has a sweet odor. Now, look at what I always tell students many times when they're in the exam. Because most of them will be like, how do you know this? How do you know that? Yeah, a lot of readings here is fine, but practice is also the best way to read. When you practice like this, you get yourself familiarized. The moment I say it is not mixable with water, I can think about what does not dissolve in water. A lot of hydrocarbon are sparingly soluble in water. You understand? So I can't conclude that. Option B was like, Roman figure 2 was like saying, it has a boiling point of 77. I can be thinking of alcohol, because I know alcohol has a boiling point of about 88 degrees Celsius. But 77, yeah, close. That's not still what I want. Number 3 says it has a sweet odor. Alcohol don't have a sweet odor. I know that. What comes to my mind now is that, okay, let me check the first 3. Does it go with something that has a sweet odor? I know it is esters. I talked about that at the beginning of the video. So now it's okay. Is ester not mixable with water? Yes. Esters are not that well mixable with water. On the other hand, does ester has boiling point of 77? I am not sure, but let me still move on. Now the next one says it is insoluble in sodium hydrogen carbonate. Now look at that. It is insoluble in sodium hydrogen carbonate. It's also a perfect example of what I want. Now, what is insoluble in sodium hydrogen carbonate? I can think about insoluble in sodium, but I know that ethanol, that is alcohol, also reacts with sodium hydrogen carbonate to give us CO2. But when they say insoluble, esters will not dissolve in sodium hydrogen carbonate. Those are the differences between alkanol and ester. So ester is making lead now. Look at the next one. It says it does not decolorize bromine water. That's a good point. Esters does not react with bromine water, will not decolorize. So in my mind now, I have concluded in my mind that what the major point that gave me an answer to this question is just because I know sweet smell. Alcohol don't have sweet smell, so I won't even go for alcohol because most of esters and alcohol can have the same similarity when it comes to what physical properties like this. I hope you understand this. So the correct answer is which of them is an esters? Esters is alkanoate. They are called esters. The reaction is always between alkanol and alkanoic. By now, you should be forming short note because very soon we are going to increase our pace. The first 10 are going to be like more like explanation. The next 10, the pace will increase, then we move like that. So esters, which of these option is an ester? I think choice D. You can see choice D. Choice D is saying ethyl, ethanoate. So that's the answer to that. So the next question. The next question is question 9. Which of the following, which are the correct IUPAC for, let's move this guy up a little bit so that we can have a visual. Maybe a little bit up. Now, I think we're at number 9. So which of the following is the correct IUPAC or names of this guy and that other guy? I don't know how many bonds are there in that other guy, but I am predicting it is 3 bonds. I am predicting. So it is, I don't know the number. If it is 2 bonds, you know it will be ENE. If it is 3 bonds, it will be what? YNE. So just be careful. Which one should we take it to be? I can't see what is there, but I will just predict it is 3 bonds because of the way. So let's make it 3 bonds. Yes, students. Let's just make it 3 bonds. So let's make it 3 bonds. So if it is 3 bonds, where is the guy? So 1, 2, 3. So that's 3 bonds. So no doubt, let's make it 3 bonds, guys. So if it is 3 bonds, it is definitely going to be a time because there are 2 carbons, 1 and 2. So that's a time. So we can start deleting. So let's start deleting. It can never be choice A. It can be choice B. Now let's check the. Let's rewrite what is there. Let's rewrite what is there. Now we have H. Watch, guys. H. This guy is CO2. I will now write it as COO. Then I will now write what was it? CH3. So this is an ester. Yes. How do I know it's an ester? The functional group of ester is RCOO. So whenever you see COO, that is what we call what? Esterification. That's the functional group. I told you OH is alcohol, or what we call alkanol. Then the other ones, OH is alkanol, COOH is alkanoic acid. These are simple notes I want you guys to be making so that it will help us as we are moving forward. I hope you are getting this. So now look at this, guys. Then this is an ester because of this functional group. So how do we name esters? We start from the back. So we name the party at the back. This is CH3. If you don't know, this is called methyl or methyl. The way you pronounce it, pronunciation doesn't matter now. Methyls. Then you now pronounce the remaining. So how many carbon do I have left? 1 carbon. 1 carbon is what? Met. If it's 2 carbon, it is et. We've talked about that. 3 carbons is what? Prop. Like that. So this is methyl. Then this one is the OH. How many carbon? 1 carbon. Methyl. Then 1 carbon is metanoate. Do you get? So this is methyl metanoate. So the first family, the first one, the IUPAC is methyl metanoate and ethyne. Hope you know why that one is ethyne. YNE, because of the three bonds. There are 2 carbons. 2 carbons are et. 1 carbon is met. 3 carbons are prop. 4 are but. So if it is single bond, ANE. If it is double bond, ENE. If it is triple bond, YNE. If the functional group is OH, it is O. If it is COOH, it is oic acid, OIC. If it is COO, it is what? Esters. That is what we call OATE. So these are things you can keep in mind. You understand? There are others. We can talk about amide. We can talk about amine. All these ones are. We can talk about another one. What we call bifunctional group, amino acid, and stuff like that. But I'm taking it gradually. I don't want to rush you. So I want you to be keeping the notes, and let's keep it very simple. This is just number 10, and we still have a long way to go. So C is also wrong. Let's check B. I think B is correct. No, B is also wrong because it is a methyl metanoate. C is also wrong. It's not ethyl metanoate. D is methyl metanoate, and D. So this guy is correct. That's the right answer to question number 9. Now you have question 10. Now what does question 10 tell us? 10 is asking you guys to, which of the following substances are all made by the process of polymerization? Now, what do we call polymerization? I talked about that the other time. That is the addition of 2 or more monomers. 2 or more monomers to form a giant structure called polymers. There are different examples of what? Polymers. So keep it in mind. There are different examples of polymers. But for now, let's just limit it with the nature of the question so that we understand. So are made of polymerization. Now we can take it one by one. Nylon is a sample of polymerization. Now how is nylon formed? Now nylons are formed by what? Polymerization of what? Ethene. When you polymerize what? When you add different monomer of ethene, you are going to have what they call polythene back. So nylon is a product of what? Polymerization. I hope you are writing. No space to write too much, but there is voice to talk. Now, on the other hand, soap. Soap is not a product of polymerization. Please note that. In fact, soap is formed as a result of a process we call saponification. Have you heard about that? If you've not heard about that, there's always a first time to everything in life. So soap is formed from saponification. Nylon is formed from polymerization of ethene. Ethene. So there are the two types of polymerization. We have addition, polymerization, and we have condensation. All these are available on my concept video. But now it's not concept, it's tackling the question and picking the right answer. So look at option B. So I said that means option A is wrong. For my explanation, A is very wrong for my explanation. I don't even know what we have here. We are the one person rubbish. It's rubbish and this person is here. So, okay. Where are we? Okay. Wow. Sorry guys. I think this is where we are. I think so. So, back to business. Question 10, we are trying to look for the one that is purely what? A product of polymerization. Number B is ethanoic acid. Ethanoic acid is definitely never going to be what? A product of polymerization. It is formed by reactions of, there are a lot of ways in which you can produce ethanoic acid. Defined when you dissolve ethanol in water is one way, and there are a lot of other ways you can produce it from ethene too, from ethene as well. But I'm not going into that now. But that is also wrong. Look at option C. Nylon, yes, is an example of polymer. It's formed from polymerization, from adding two monomers of ethene. Now, the next one is artificial rubber. Now, when you see artificial rubber is also a product of what? Rubbers are formed from what? From monomers of what we call what? Now, there are two types of rubber anyway. If I want to talk about that, there is natural rubber and there is artificial rubber. Now, when we talk about rubber, there's what we call, I don't want to go into details, but there's what we call isoprene. That's the monomer. They have what we call isoprene. Isoprene is written as 2-methyl isoprene. And the other type of rubber, we'll call that neoprene. These are monomers of rubber. So rubber is formed, these are monomers. Monomer means a single unit that is now brought together to form a giant molecule. So by and large, my point is this guy is correct because these two options here are formed from what? From polymerization. There are other types, styrene, polystyrene. If I continue to name them, we won't leave here. So, but for now, let's just keep it simple. And keeping it simple, option C is very, very correct. So, not that. The next question is question number 11. Now, for question number 11, we are told that the IUPAC names for this guy is that. Now, naming this kind of stuff is very easy. Let me let you know that. It's very easy. But for us to see, the logic is to start naming from the point that is closest to the what? To the double or the triple bond. That's the logic. Now, if I start naming from the front, you are going to see that I will say the first carbon, the second carbon, the third carbon, the fourth carbon. So it will be very far. But the double bond is what? Closer to this side. So if I start my counting, definitely I need to start from this guy 1, then I call this guy 2, then I call this guy 3, then I call this guy 4. So basically there are 4 carbons. There is a double bond. So if there are 4 carbons, what will I call this stuff? Then I'm definitely going to call it what I know. 4 carbons are what? Boots. So I'm looking for answers that end with boot. All answers that is not boot here, I can decide to what? To cancel them. That's the first way. Now another way of checking is, okay, Which other thing do I have attached? I have the alkyl group. Here is the alkyl group attached to this guy. It's attached at the third carbon. Look at the carbon 3. There's what? A methyl group or methyl group. So if I want to name now on the third carbon, I have the methyl group. So I have 3 methyl. Then I will now say but on the first carbon, I have the what? ENE, the double bond, which is ENE. So to name this one is 3 methyl. But where's but coming? There are 4 carbon. But what? On the first one, there is double bond. But 1. Then double bond means what? ENE. So which of the options goes with what I call now? 3 methyl, but 1 ene. Let's start. Okay, option D. I hope you guys are getting this thing. So it's more like knowing the simple rule. The first one is look for the longest carbon chain. After looking for the longest carbon chain, the next thing you do is to look for the one that has what, that is closest to the double or triple bond. Start naming from there. Now another thing is what? Priority order. Because in some cases you have functional group. If it is functional group is greater than double or triple bond. We still talk about that when we see questions on that. So the next question will be number 12. And doing that, we have to move this guy up. So question 12. Now, the question 12 says, what is the structural formula? I told you now we have to increase our pace. Now, what's the structural formula for ethanoic acid? Now, alkanoic acid is COOH. 2 carbon will give you 8. Now we have to increase the pace. So COOH is the functional group, correct? But this is not 2 carbon, so it is wrong. Wow. Sorry, guys. I have to change to what I am to use. Now this is wrong. Fine. This is 2 carbon COH. It is COOH. That's the functional group of oic acid. So the next one, 1, 2, 3. This is 3 carbon. 8 is what? 2 carbons. Now this is 1, 2, 3. This is also very wrong. We are counting the carbon because 8 means 2 carbon. So this is 1 to 2 carbon. This guy is 100% correct. Now into the next question. The next question says starch can be converted to a tea alcohol by process of converting starch to alcohol is called what? Very simple, fermentation of sugar, fermentation of starch. When you convert starch to alcohol, this is called fermentation. Now, under fermentation, there are a lot of things I can still talk about. The process, explanation of the process, and the type of enzymes and their work. Because UTM will ask you questions based on that too. That has been treated in my topic on the concept video of alcohol. You can watch it if you have time. But if I see question on them, like I said, I will definitely go into them. Question 14. Look at this guy. 14 says, hydrogenation can be effected by dash. Now, that is just definition. Now, how do we define hydrogenation? It's the process of addition of hydrogen. I get it now. Addition of hydrogen in the presence of catalyst. So when you add hydrogen to an alkane in the presence of what catalyst? What is the catalyst? Nickel, platinum, palladium. Nickel, platinum, or palladium. These are what is common. I'm telling you what is common in UTME. UTME like structure. They like concept. So if you know concept, it's very, very simple. So now, hydrogenation is the process of adding what? Hydrogen to alkynes. I said alkynes, please, not alkane. You know why it is not alkane? Because I told you addition reaction is hydrogenation. And when you talk about addition reaction, it is common to what type? The what? 2 unsaturated. What are the 2 unsaturated? Alkanes and alkyne. Do you understand this, please? You have to understand what I'm teaching. Addition reaction is common to alkanes and alkyne. The first member don't undergo addition reaction. They undergo what? Substitution reaction. So simple. So if you are saying hydrogenation is addition of what? Hydrogen to an organic compound in the presence of catalysts. What are the catalysts? Nickel or nickel, platinum, or palladium. These are the 3 catalysts that any of them can come up. Just pick it. So let's see the options. A says removal. Hydrogenation is never removal of hydrogen, it's addition of hydrogen. Please help me check time. I only want to use 45 minutes. So the next one says the addition of hydrogen to alkane. You can't add hydrogen to alkane. That is why this guy is wrong. C says the addition of hydrogen to alkynes. Yes, in the presence of catalyst. Now, that is the answer. C is correct. D says removal of hydrogen. Hydrogenation is not removal, but addition. Look at that. This is also wrong. You don't add hydrogen to alcohol. It's not that. So that's the answer to that. I think that is good. The next one says, question 15 says, when excess ethanol is heated to 145 degrees Celsius, I did this in my online class, we said offline, while I was teaching alcohol. When excess ethanol, when I was teaching, talking about the production, how ethene is being prepared. I told them the one you tell me we asked them is the simple reaction of this guy C2H5OH at a high temperature in the presence of a dehydrating agent, which is always H2SO4. When you remove water from this, remove H2O from what I've written there. Yes, student. What are you going to have? So you are going to see that definitely you are going to have oh my god. So moving up there, I'm not going to move up there again. So let me just stand there and be picking my pen. So basically, so this guy is going to be, when we remove water, definitely going to have C2, we're going to have C2H4. So this is one of the simplest way to produce ethene. You can see two carbons are 8, then C2H4, general formula of ethene is CnH2n. So this is ethene. Look at what the question is asking you, direct question. Now, when excess ethanol is heated, when you heat something, you are removing water. In the presence of concentrated H2SO4. What is the work of H2SO4? It is a dehydrating agent. So, what is the product that you are forming? What's this product called? ETHENE. It's an unsaturated because it had double. How do I know? The general formula of alkanes is CnH2n. I will just look at the first 2. 2 times 2, 4. So that is that. If it is 2n plus 2, is the first one, which is the alkane, which are saturated. I hope you guys are getting this. This first video is for you guys to enjoy and for me not to be at ISP. So what's the answer? The answer is nothing but what? We call it, the answer to that is ethene. Now, look at option. I love this. Now, ethene. If you check the option properly, none of this guy is ethene because it is not ethyl. It is not this, it is not acetone, it is not ethanoic acid. So the correct answer is diethyl ethanol. Now let's talk about ether and their functional group. Ether are actually called what we call alkoxy. They are also known as alkoxy. So please, if you don't know that, you can always keep that at the back of your mind. When we say alkoxy, they are having a functional group of what we call ROR. I'll help you out. So now the overall reaction, because this thing has always been a kind of a problem for some teachers as well, like how are we going to pick this? The final product is ethene, but if the temperature is not that high, it is not going to yield ethene. It's definitely going to yield what we call what? Diethyl ether. Now how will I write diethyl ether? So that means, look at this guys, CH3. I told you their functional group is O. Then in it you have O, then CH3. This is what you are going to have first. Now, as you now increase the temperature, this guy will be absorbed completely. Then we are going to be left with what we have C2H4. Now, what am I trying to say? It begins with this. I don't know, they are going to test you full reaction. Then it comes to this. Then finally come to what? To this. So please note that. Now, when the ethanol is excess, another key point. Now, when normal, or I said normal, when limited ethanol is heated, the final product is ethene. When excess ethanol is heated, the final product is what? Dimethyl. You can see, everybody knows this is methyl, this is methyl. So dimethyl ether. What we call ether is when the functional group in between is what? O. So anything that have ordinary O in between is called ether. Ether, or what we call what? Alkoxy. No space to write. Let me manage it. Alkoxy. Alkoxyl are also called ether. Not esters. Remember, esters is COO. Those ones that are characterized with sweet smell. I hope you are getting there. Yes, the next question, I'm going to move this guy up. I'm going to move you up. Sorry about that. So I'm going to move this guy up. Yeah, so now we answer 17, 18, 19, then we move to the next page. Now, question 17 says, which of the following is acceptable as an organic product of the reaction between ethanoic acid and, oh, wow, I missed the question, thank you, admin. Now, I was told I missed a question that when ethene gas reacts with fluorine gas to produce 1,2-dichloroethene, the reaction is, I told you, what type of reaction does alkanes, ENE and alkanes undergo? They undergo what? Addition reaction. So don't disturb yourself, simple thing. If it is alkane, ethane, it is what? Substitution reaction. So addition reaction can be explained in 3 to 4 ways. Reaction with hydrogen chloride. You understand? So all those type of reactions are said to be what? Reaction with bromine, halogen. So but you know we're going to talk about bromine, chlorine, but it does not react with iodine. Time does not react with iodine, but I'm not going to that because you guys are not A-level chemistry students, so I'm only limiting it to what you need. So ethyne reacts with what? Chlorine to give you 1,2-dichloroethane. Dichloroethane, not ethane. That's a typo. Don't worry. That is not what I'm here to do, but I can correct error. So because when unsaturated hydrocarbon undergo the addition reaction, they give you what? Saturated. I get it according to Markov-Nikov rule. I'm not into that anyways. 17. Have I used up to 30-minute admin? Okay. 25. Okay, 5 minutes. Okay, thank you. Now, which of the following, because I want to answer 50 questions so I can know how to increase my pace. Which of the following is acceptable as the organic product of the reaction between ethanoic acid and ethanol? Look at this guy. I've talked about this before. I told you when alkanoic reacts with alkanol, it is called ester. That's esterification. Okay, for 30 minutes or for 45 minutes. This is 40 minutes now. Oh wow, I need to increase. So I will do 25. Let me be fast. Now, which of the following is acceptable as organic product of reaction between ethanoic acid and ethanol in the presence of acetic acid catalyst? We've talked about this the other time. We said it is esterification. So ethanol, ethanoic, it will give you what? We are going to have ester. Esterification will give you what? Ethyl ethanoate. But we can write it for clarity's sake. Watch this, guys. Ethanoic is C2CH3 COOH, functional group of alkanoic, combined with ethanol is C2H5OH. I told you about the reaction. It's so simple. What happened in the reaction is, well, look at this now, guys. We have this guy, the water that is going to be a substrate. This one will produce H, this one will produce OH. So when H combined with OH, it gives you what? H2O. So you now write the remainder. That is the remainder. What's the remainder here, guys? The remainder is, you can see, a CH3, COO from this guy, then C2H5. That's the major product. Then plus H here plus OH there, which is what? Water. So that is the reaction. So this is the major product, what you need. And how do you pronounce it? I told you the other time. Start from the back. Name their key group at the back. 2 carbons. 2 carbons is what? Et. So their key group at the back is what? Ethyl. So ethyl, which has ethyl there. All other options has no ethyl except A and C. Except A and C. So far we have A and C. So definitely, then name the other one separately. How many carbon remain? 2 carbon. What is the carbon? 2 is called ethanoate. So that's just that. So this is ethyl ethanoate. So that's that. The second time I'm doing that. Next time I'll be very, very fast when I'm dealing with that. The next question should be the question on question 18. I've done this one before. Handling of oil may be achieved by dash. Now, this is what we call hydrogenation of oil, which we defined the other time. So I don't think we should have any issue with this as well. So when we add oil, it simply means we are actually adding hydrogen to oil in the presence of catalysts. What are the catalysts I talked about? Nickel, platinum, or palladium. So don't make mistake. Every question keep repeating itself. That is treating oil with hydrogen in the presence of catalyst. So that is handling of oil is also called hydrogenation. So note that, hydrogenation. Now, question 19 is IUPAC. I'm going to do that also in no time. So question 19 is also IUPAC. Then we have to name this. Now, it's more or less like what we did the other time. So we don't need to waste our time. So to see the option of this thing, but we don't even need the option. But let's just see if this option A is correct. Now, this first option, let's check if it is correct. We first name it from the one that is close to the bond. So if we start from 1, 2, 3, if we start from here 1, 2, 3, okay, fine. So it will be 3, 4. Look at this now. If I start from the point, because there is a long chain on the third methyl and what? Methyl. If I start from the point, it will be 1, 2, 3, 4. So I will have 3 separate number with comma 4. 3 plus 4 are 7. Lowest sum rule. That's the law. I am a very good organic chemistry teacher, not even organic chemistry teacher, complete chemistry teacher, but I teach according to your syllabus. Your syllabus doesn't require you to know too much of concept for this level. If you are doing Duper chemistry, there are other things you still need to know. You understand? So let's keep it simple. Let's keep it 3. Now, if I start from the back, see, 1, 2, 3, it will be 2, 3. The law states the lowest sum rule. Which one has the lowest sum rule here? 2 and 3. So you should be thinking about 2, 3 and not 3, 4. Lowest sum rule. So let's say on the second carbon I have in fact, if I even start from there, it will be 1, 2, 3. The something will be on the third carbon. The double bond is on the third carbon, which is far from starting 1, 2 on the second carbon. So if I start from there, it will be 2, 3. How many methyl? 1, 2. I mean, the first methyl is on 2. The second methyl is on 3. So 2, 3 dimethyl or dimethyl. I don't know how you pronounce. Then how many carbons are there? 1, 2, 3, 4, 5. 5 carbon is pronounced pent. Pent on which, you know, I'm starting from this side now. 1, 2, 3, 4, and 5. So on which carbon atom am I having the double bond? On the second and the third. So that is pent 2 in. If I have started like this, 1, 2, 3, 4, between the third and the fourth carbon, that is pent 3 in, which is not going to pay me. And I will be having something like 3, 4, which is even bigger than what? 2, 3. So that's that, guys. So the correct answer is not A. So the next, we can check the correct answer from the next guy. So let's see the next guy here. Now, where's that guy? I think I'm here. Let's see. Okay, the time is not on my side. Okay, I think it's here. I think it's here, the one that is not actually seeing well. So look at option B. I think is what methyl do we want to? When spent 2, 3. Am I right? Is it 2, 3 something? Pent 2 in. So that's the correct answer. It's not 3, 4. So this option is correct. This guy is very correct. So it is this guy that is correct. What makes the first option to be wrong is because it is what? Pent 3 in, which is supposed to be pent 2 in. So the next question, I may not be able to see it well, but I can use an idea of what? Of being an expert in the field. So look at this. I have different structure, I guess. So they said, which of the following chromate of ethanol? Maybe we should skip. I just think we should skip. A lot of things are cut away there. So. Even the next question, I don't know where it started. Maybe they said a drop gradually, a drop of what? So maybe we should just another question on this side, basically, and come to this side so that we can actually, how many minutes have elapsed my time? Right? 2 minutes more? Okay, fine. So let's just do maybe a few questions more. I think this side has cut a lot. See, it has cut a lot. But that does not, okay, I think this one is more like, which of the following? I think there should be which. So we guess, I think that organic compound undergo, is it oxidation with bromine? Oxidation. Is it oxidation? It has cut, okay, the time. I just want to do some more, maybe in the next video. I think it should be oxidation with bromine. Maybe oxidation with bromine water. So, actually, the answer to this one should be alkanes, because we know addition reaction is, you understand, is common to what? Unsaturated hydrocarbon. So I can't see anything that is cut. That means I'm going to be focusing on this in the next class. So guys, let me stop here. Now I will continue this. I told you I have more than 350 questions to solve. This is just the first part. And if you actually, I'm going to take everything down. It's a pity this side is cutting. I just hope when I go to the next page, it won't cut. But for this page is cutting, then I'll focus on this page when I see you. So I'll see you guys in the next video. Don't forget to subscribe and like. And also drop a comment if you want us to continue. And if you don't want us to continue, we can as well stop. But if you think it is helpful, you can just subscribe and click the notification. See you guys soon. Do have a wonderful time. Enjoy yourself. Bye.